I'm here to talk about the biggest buzzword in the industry today, which is AI. And we're talking about how this applies to real-time live video and all the fun things we're doing with this. So first and foremost, why should you listen to me? Well, I've been at this for a very long time. You guys might have heard of Red 5 from back in the Flash days. We were the first guys to reverse engineer RTMP and create an alternative to the Flash communications server back in the day. And actually the name of our company, Red 5, is all about it's the call signal for Luke Skywalker. So our vision was we were the Rebel Alliance going against the evil empire, which was Adobe, and blowing up the Death Star, which was the Flash communication server. So that was kind of our roots. Since then, we've been working on all kinds of really cool stuff. We've modernized the Red 5 platform. We're mostly known for WebRTC delivery and streaming at this point. But we're doing a lot of stuff in AI, and so I wanted to talk about that for this presentation. Oh, there's my nice little remote. Yeah, so just a quick bit about our company and our products. So we have Red 5 Pro, which is your self-hosted. It'll auto-scale on top of other cloud providers or on-prem deployments and other things like that. Red 5 Cloud is our fully managed platform as a service. And then we have SDKs for various platforms that kind of work with both of these. And then this other thing that we have is a TrueTime Solutions, and these are like fully baked apps, which we make open source that people can take and mix and match and make their own applications out of them, or use them out of the box if it works for you. So I wanted to talk about LLM or VLMs and detecting things in real-time live video. We're going to go over a quick system architecture, how we've done it, and our approach to this. Talk about a few real-world applications, and then just talk about where we're going with it. So some of the use cases where this is important. You've got surveillance apps and monitoring. So we do a lot of stuff with Department of Transportation and traffic monitoring and looking for bad things in the streams. And when you have a video wall of lots of video, it's hard for a human being to be able to monitor each of them and find really small, minute details. And so little AI agents who are watching the streams turn out to be a really good solution for that. In broadcast, I've got this guy flipping people off. That's one scenario. Other things are nudity and other stuff where they want to get rid of that. In a live broadcast, this same technique can be used for that. Other stuff is social, media, user-generated content. You've got bad things happening. They want to blur it out, or they may just want to shut it down immediately. I kind of use the most extreme version. Somebody's doing some violent act in a social media stream. They obviously want to catch that, but others are like nudity and things that they don't want on there. So I'm going to talk a bit about real-time frame extraction and then getting that sent to an AI engine or AI model to actually look at what's happening in it and give you some feedback on it. So this is kind of step-by-step. Create the stream. So we handle lots of different ingest streams with the Red 5 system. So if it's traffic camera or RTSP, we still support RTMP. WebRTC ingest with WIP is still a standard thing too. It doesn't really matter what the stream is coming into the platform. And then that's where our origin node handles the ingest of that. Then we have a thing that we call the Brew API that extracts the image from the live stream, passes that on to an AI process running a visual language model. And then this is kind of an optional step. We can re-encode the video. We can add bounding boxes around the thing that was bad, or the example, somebody flipping somebody off they can blur out the hand, So this is manipulating the stream coming out. And then obviously the rest of the flow, it can go out of the Red 5 system onto a client who's watching the stream. This is kind of another visualization of the same thing, but this is a very specific one that we're working on for an AI-based ad insertion company. So they want to get real-time frames out of it and then manipulate those and then change the video going out. And so this is using an SRT ingest, going to a Red 5 Pro ingest point. The Brew API is doing its business, handing over to the VLM. and then it goes back out as an SRT stream to their broadcast facilities. So I keep talking about brews. Well, we have this thing called a cauldron. It's like the witch's cauldron, and you can make brews for it. So this was our concept with this. We use this for doing things like transcoding. I know the guys at Stream were talking about streaming, like doing simulcast with WebRTC and having to have the client generate the multiple bit rates from the source. Downside of that, of course, is you've got bandwidth constraints a lot of times, and then you can't always do that. So we take a server-side approach to doing that. We use Cauldron to generate multiple bit rates, and then those can be used to do the shifting up and down with WebRTC streams later. We also have a compositing engine we call the Mixer. I know not the most creative name, but it works. And then the frame extraction is stuff that we're talking about, and writing of new video, which is the encoding part. So decoding and encoding. It's optimized for latency. It's also built for CPU. We haven't really focused as much on GPU, mainly because all the AI engines are eating all of them up, and getting access to these things is crazy and they're expensive. So that was the main reason we did it. And then the brew is a C++ API that you can use to actually write these very custom things. So first of all, just anticipating that we're going to send a raw frame from a video into the language model, this is what we do to actually configure it. And this is just one use case, which you could take a lot more, but I'm going to show you how we did it for detecting things like fire in a live stream, okay? So basically we say, score on a basis from 0 to 100, and then we've got predefined categories. This actually helps speed up the model so that it's like looking for very specific things. If you have it really broad, then it's much slower, and that doesn't really work great for real time. And then, we're using a prompt basically to do this. And then we are getting the prompt actually to have it return very specifically formatted JSON so that we can parse it and use it later. So here's the prompt. It's kind of crazy, but the main thing is this: 0 to 100, rate how likely things are to occur in this traffic camera. Is there a traffic, emergency vehicle? So we're actually giving them accident, emergency vehicle, like getting fire, etc., road hazard, congestion. Respond in JSON just like the below. So we give them an example JSON file, right, of the format we want. And then the thing just works, which is remarkable. In this case, we're actually using Fast VLM, which is a Apple-made product, and so it's kind of the pre-release, kind of experimental version, and we're actually running that on a server hosted on Oracle Cloud to do this. So the extraction part, this is getting live video coming in and then extracting that and putting it into PNG, into a bitmap format, right? So that then the VLM can read it. So we're currently running a version of this that accepts, H.264 ingest streams. We decode the frames into YUV, which sometimes we can actually skip the other bitmap format, but usually when you're transporting it, you want to compress it a bit, so we use like a PNG to compress it. And that's basically it for that step. And then we send the data to the AI model. When we were looking at this, we had a lot of choices, right? We could upload it to a cloud storage, have it sit there, and then the VLM is like looking for new files that are arriving. This works okay, but it does add a lot of latency to the experience because you got that upload speed. We're actually optimizing this, and we're going to provide a service for people that want to run their own language models and want to use an S3 bucket. Or we could implement like an NFS in the cloud and then do a shared file service so that the GPU instance is pulling from that. That would work pretty well. Or the other option is like stream it with like something like a WebSocket. So we're actually streaming the image data to the VLM, and then it's a push mechanism to the guy instead of it sitting there watching and pulling it. The other option, which I don't think is a very good one, is try to run everything on the same machine. Really powerful GPU instance, runs the media server, runs everything. Well, we opted not to do that. And the one we kind of settled on was the stream the data using a WebSocket to the VLM instance or the computer that's running that. All right. So the next step is once the AI detects or reads the image, right, that's been extracted from the video, we get a response back in that JSON format that you guys saw before, right? And then we could actually optionally modify the image, right, and then push that back into the encode step on the using the Brew API. Actually, this is probably a little bit out of order. Like, we'd probably send the response first, then grab that and modify the image. So apologies for that. I do notice a mistake in my slide. And then we would also push the metadata, which we have a Kafka-based messaging system with Rev5, where it passes it throughout the cluster. And so every edge node receives that message and can pass it back over to the WebRTC data channel for each of the clients so that they could, if you wanted to display it client side, whatever the alerts are or everything, you could do that there. All right. And then in code, again, this is kind of an optional process that we can do, but we can take the raw frames. If we have to convert it from PNG again, we'll convert it to YUV, and then our system will actually write that and encode it live. And then it's a modified video going out of the system. I guess hit the volume. There you go. So here's some of the results that we had. So you've got, this is like the frame that we captured from the video. And then the coolest thing about this is you can say, okay, they think there's an emergency vehicle. Maybe there is, I don't know. But pedestrians 100%. Congestion is 90%. So it's saying a large group of pedestrians blocking multiple lanes of highway traffic. It appears to be a protest or a demonstration. You can already see how useful this would be to somebody running like a huge video wall, trying to detect these things. If it gets an alert that describes exactly what's happening, then they can act on it. Right, here's another one. This one I like a lot. Horses are running loose on the highway, potentially creating a traffic hazard, you know? So like, it's very effective. So I'm going to show you a little video of this in action. Let me switch to that. Of course. Okay, so in this example, we've got this. This is pre-recorded because we're running all our tests on this, right? So it was actually one of the biggest challenges was finding good content where it had these kind of incidents in it to be able to run the test. But this one's a particularly good one, as you'll like. I don't know if you, especially the guys in the back seat, probably can't even really tell this is happening, but there's a subtle amount of smoke happening here, and the VLM has already detected something, right? And now it's getting to a point where it's going to get really high, and we skip ahead just to make a video. Like otherwise, it's super boring to watch this for 6 minutes or 35 minutes, right, to see the whole thing unveil. So now it's actually, you know, you see the congestion as smoke is coming up. Now it's giving an alert.
Incident on I-575 North, past I-75, camera 500.
Yeah, so it's using the, you know, the VLM voice. This is like text to voice, you know, technology just to be able to read out what the report is. So we could probably skip ahead just a little bit because I think you guys get the point. I don't want to spend a tremendous time on this.
Camera 500.
But now you can see they definitely know it's fire at this point. And the cool thing to notice here is this is 2 minutes into it, right? Or it's actually, I think it detected that it was certain that it was fire well into this. And that's 2 minutes of a wildfire starting.
Emergency responders on the scene for wildfire on I-575 North.
Right, but if you look at the actual video, it took them 17 minutes for those firefighters to show up, right? Now imagine had this system been in place they would have been there a lot faster if we could alert them right around 2-minute mark. Or a person who's monitoring the cameras could be like, oh, I actually see something. They may even detect it before the VLM if they're alerted that there's something happening, they can move on. All right. Oh, we're going to move up to slideshow. Yeah, so clearly this is like using video extraction, and it was kind of the harder part of this, but we could also use this for audio. The Jitsi guys pretty much showed like a very similar workflow, right? Of using audio, ripping audio to wave in this format, which is what you guys were doing as well, and then pass it off to an AI engine to do all of this work. We're about ready to release this as one of our true time solutions. It's a complete meetings app. So it's a bit like the Jitsi Meet. It's like Google Meet. It's, a variety of others like this, right? We've got live transcriptions working in it as well. We're actually using the NVIDIA Parakeet model, which is actually very efficient and can run on CPU, which is pretty interesting, like how fast the thing is. And I was actually talking with Will Law before this presentation. It's like a lot of times you just got to wait for the stuff to come out, right? And that's exactly, I know the Jitsi guys are doing that too. It's like you just sit around and all of a sudden there's more innovations happening and you can apply it. So let's see if we can fire this up. All right, I'm going to join this call. I know Rebecca was going to join it too. Let's see. Oh, whoops. And I think there's probably going to be a little bit of latency on this stuff because of just the internet. Do you want to volunteer? You can be phone.
I'm phone.
So let's see some live transcriptions come out of this. Yeah, so here we are in Poland, in Krakow. Super cool city, and thank you guys for putting on a really great party last night too. As you can see, this is incredibly accurate. I'm obviously speaking really clearly. Maybe you could say something too so we can see another participant.
Yeah, sure. Is it going to show transcriptions on this device also, or is it only on your
device? Yeah, if you click this closed caption button. No, it's hidden under the ... Oh man, they didn't add it to the UI. Oh wait, maybe it's here. No, it's totally fine. There's no reason why it won't work here. I think they just didn't add it to the mobile UI yet. So, yeah. But there you go. I mean, this is a pretty efficient transcription. This is running on the lower end model of GPUs running on OCI or Oracle Cloud. And yeah, we've seen really good performance. And we took a very similar approach to the Jitsi guys. I was really happy to see your presentation before this, and like using separate streams, sending to so we could actually isolate which participant is saying what. You know what I mean? Otherwise, it just comes back as a single, like you don't know who said what. So since we have individual streams, we got Rebecca back there. You could say something. I know you don't want to say anything, but this silent participant. All right. But yeah, this all this code, here, I'm going to hang up. Thank you. I'll take the phone back. All right. So this is going to be, we're releasing this as open source, available on GitHub. You guys can take and mix and match as you see fit. We've also got, I know it's a React components for this, so it's pretty modular and pretty easy to work with. But we're also releasing for Rev 5 Cloud the frame extractor, which you can configure to upload to S3, compatible storage as you see fit. the wave extractor as well, so that you can do it either video or audio. We're going to also package some language models with the system to have available. So if people want to use it out of the box, and we've got our WebSocket solution going, you can use that too. And then the idea is also to provide a pretty simple API to configure the VLM to do whatever you want. And then everything that's on Red 5 Cloud can be used on Red 5 Pro too. So if you want to deploy it yourself, manage it yourself, run it on your own cluster, that's totally fine. And then the true time meetings, we're also going to have that part of Red 5 Cloud, so you can deploy a meeting, customize it a little bit, and then kind of make it your own branding. Or then you can take the code if you want, deploy it yourself, do whatever you want with it, which is also a pretty cool option. So yeah, I think I whipped through this faster than I expected, but it looks like I'm on time. So where does it go from here? I think the key takeaway here is that these language models are changing quickly, and if you have a concept that you can't quite pull off now, I think the concept's probably valid, and you'll be able to do it pretty soon. I think this is just the trend that's happening with this stuff. And I think, getting language models which are very specifically trained for certain content, like I said, well, one thing that we were doing with our frame extraction model is it has no history, it has no memory, right? If you start adding, hey, remember everything that happened before, so you want to find somebody who's loitering in a scene, then you would need that kind of model. The reason this is so fast is because we're using a single frame. Just analyze what the heck's in that. Don't remember anything else. Just tell me what you see. That's it. I think as these systems get more fine-tuned, we're going to have better power to be able to do things like detect a loiter on a scene or something that's very concerning that needs the history. The other trend is also running this stuff on mobile phones and locally on edge compute. The power for this stuff is getting better and better. You got WASM to run native code in the browser. You've also got the ONNX, I guess is what they call that, but the Open Neural Network Exchange, which can run VLMs or language models on the devices itself. And then, of course, having open APIs and real-time infrastructure is really critical to make this stuff happen. And in fact, in that, just to give you an example of a WASM kind of AI engine in the meeting app, again, sorry, I should have just kept my same meeting. And again, this is a bug. It thinks I'm entering a credit card for some reason. But let's change out the background. Change virtual effects. I can do this, this kind of stuff, right? And so this is actually doing it client side, right? I'm not even streaming out to the server right now. Well, actually, I technically am, yeah. But it's doing all of this locally on my machine. It's actually using this, Media Pipe, I think. And that's actually what Google Meet uses as well. We did a whole tutorial on this, which is pretty cool. But yeah, this is an example of the kind of edge computing happening today. And I think it's just getting crazier and more interesting. So that's it. If you guys want early access to any of the stuff that we're working on right now, please get in contact with me. I'm Chris at red5.net. You can find me on LinkedIn. I really don't use social media anymore, so probably not the best way to find me there. But yeah, that's it. Thank you.
Question time. Saul. Yep, it's coming.
Thank you, really cool stuff. I remember running into Red 5 as a young Timmy when I was starting, when it was just mostly streaming stuff.
Yeah.
So it's very cool to see you guys still around and kicking some ass. I really liked the video thing and how you guys did the, like putting the confidence level in a graph to sort of show it. This is really nice, rather than not see anything and suddenly, boom, the alarm.
Yeah.
I was wondering, because I missed the first few minutes, unfortunately, if you had mentioned how many frames per second are you running through this thing? Because, it can take some time to process, I would assume.
It doesn't in this case. That, like I said, we're using the Apple fast VLM to do the image detection, and it's wicked fast. So we're actually sending it. I think that test was every 1 second.
Every 1 second, so 1 out of 30 frames, let's say.
Yeah. And a 30 FPS video, obviously, it's like it depends on the video, but we can run it much faster. We just found it. You got to find the sweet spot, right, and not overload the system. But the fact that language model is able to run on a phone gives you the idea of like the power if you put it on a server, right? It's like crazy what you can do with it.
You're running like on hosted Macs.
Yeah, you can do that. Yeah, but it also supports NVIDIA GPU as well. So
right.
it's like there's a whole research group behind this. It's not just Apple. Like they're kind of making it an open source thing. So
What was the name again?
a fast VLM.
Okay, I'll check it out. Thank you so much.
Yeah. But I mean, I think the idea is you can apply this to OpenAI. Like any of them, you just hand it over, and like I think different use cases probably use different models and be better performance depending on what you're trying to do, right? Yeah.
So, yeah, thanks for the presentation. Really nice, really interesting. Just wanted to ask, because I looked into the Parakeet when they first got it out. I don't remember, I think there were some limitations, though, regarding the amount of languages it supported.
Yeah. Initially, it was English only. Now they've added like 7 different ones, I think. But you have to tell it ahead of time that what the language is you're detecting.
Okay, so it has no auto detection in place, or
Not yet, but I think they're going to get to that.
Yeah, that's really interesting.
But I think it's fast enough, as you saw, like just coming back, that you could probably run a translate from the text and then get it that way. So there's like a couple of hops you could do to make it work today, but I think it's just going to get better and better. Yeah. I was actually kind of disappointed because I couldn't try the Portuguese with our Brazilian team down in, but yeah, I think it's getting there. I think this is a classic example of like, it's just wait a little bit,
Yeah.
So,
Okay, thank you.
yeah.
Any other questions? Okay, I think that will be it. Thank you very much, Chris.
Thank you.